In today's video, we will learn about the activity series of metals. Here, the metals in general have the tendency to lose one electron or more valence shell electrons, right, while combining with other elements. Here, this is because metals have very low ionization energy. Now, the chemical reactivity of a metal in general is linked to its valence shell electron or the tendency to lose the valence shell electron to form the positive ion known as the cation, right? Here, the greater the tendency to lose the electron, more the metal is reactive, right? And the metal, when listed according to their electron releasing tendency, the list or the information is called the activity series or the reactivity series. You can see here some metals that are arranged according to their reactivity, right? So the topmost position is gained by potassium and sodium that are very reactive because they only have one electron in their outermost shell, and the least reactive is gold, right? So this is the reactivity series of metals. Now moving ahead towards the salient features of the activity series. Now here the electropositive character, that is the tendency to form the positive ion, decreases down the series. Here the most electropositive metals such as the alkali metals are on the top of the series, right? Now the second salient feature is reaction of metal with oxygen. That means all metals down to and including the mercury in the activity series combine directly with oxygen to give their respective oxides, right? Now here the activity series or the reactivity decreases down the series. Here in general, metal when reacts with oxygen forms the metal oxide. Here, except the alkali metals such as sodium, potassium, and alkaline earth metals such as magnesium and calcium, the reaction is slow at ordinary temperature. Here, these metals are very reactive, that's why the reaction is very fast. But in other metals, the reaction is very slow at the ordinary or the room temperature. Here, we will see the reaction of sodium and potassium with oxygen. So here, sodium and potassium reacts very spontaneously with oxygen to form sodium oxide and potassium oxide. Now here, these metals are very reactive with oxygen. That's why these metals are kept in kerosene oil, so that they cannot come in contact of the air for the reaction. Now talking about metals like sodium, potassium, calcium, magnesium and zinc that burns in the oxygen, right? Because they are very reactive. Also, sodium burns with a bright golden yellow flame. Now talking about the magnesium, that burns with a dazzling white light. So here when magnesium reacts with oxygen, it forms magnesium oxide, that is formed by the burning of magnesium, and the burning of magnesium produces dazzling white light, right? Now talking about zinc, that burns only on strong heating in the presence of oxygen to form the zinc oxide. So this is the reaction of metals with oxygen. Now moving ahead, here are some examples more, that is aluminium when combined with oxygen forms aluminum oxide. This reaction occurs at very high temperature. Also iron only rust very slow in the presence of moist air to form ferric oxide or Fe2O3, that is iron oxide, right? Here also iron do not burn on strongly heating but glows as red hot iron and forms iron oxide. Also here copper burns into a black colored substance, that is copper oxide. Here silver and gold do not react with oxygen at any temperature or at very high temperature. Talking about the third salient feature of the reactivity series is the reducing power. So as the tendency of metal to lose the electron decreases down the group, that means the reducing power also decreases down the group. That means the alkali metals are the strongest reducing agent among the metals. Now the fourth property is the reaction with metal and water. So the reactivity of metals with water also depend on the position of metal in the activity series. As the element present down in the series, that means its ability to react with water is decreasing. For example, here you can see sodium and potassium, right? Here sodium when react with water, it react vigorously, right, and forms sodium hydroxide and releases hydrogen gas. Also when potassium reacts with water and forms hydrogen gas very vigorously, right? Here calcium reacts very less violently, right, and forms calcium hydroxide and hydrogen gas, while magnesium displays hydrogen from boiling water. That means this water is very hot. That means magnesium only reacts with hot water to form magnesium hydroxide and hydrogen gas. Now here, less electropositive metals like such as aluminium, zinc, iron react with steam. That means they react with water at gaseous state, not with liquid water, right, to form their particular oxides and release hydrogen gas. Here the main difference is, here the metal hydroxide is not formed but the metal oxides are formed, right. Now the least reactive metals, right, they do not react with water at all. Now the fifth property is the reaction of metal with the acids. So the metal that are present above the hydrogen in the reactivity series easily displace the hydrogen from their acid. For example, active metal, dilute acid, when reacted they form the metal chloride or metal salt, and hydrogen gas is released in this, while the metals like copper, they do not easily get react with the acids. Now here, the sixth property is the displacement reaction. So, the position of the metals in the reactivity series describes this process. So, the more reactive metal will displace the less reactive metal from its salt. So, here you can see the example, that is iron is displacing copper from copper sulfate salt to form iron sulfate, that is greenish in color, while the copper sulfate is blue in color, and the copper metal released as pure. So this is due to because iron is present above copper in the reactivity series. That means iron is more reactive than copper. That's why it easily displaces copper from its salt. Now the seventh property is the reduction of metal oxide. So oxides of metal like potassium, sodium, magnesium, calcium, aluminium are not reduced by common reducing agents such as hydrogen carbon or carbon monoxide because they are very reactive metals. So however, metal oxides below aluminium in the activity series can be reduced by heating with carbon, carbon monoxide or hydrogen. Here you can see the metal, that is manganese oxide, when reacted with aluminium forms manganese metal and aluminium oxide. So this is the reducing power of manganese that helps in getting reduced by aluminium because aluminium is very reactive, and such kind of reactions are very exothermic. That means very large amount of heat or energy is released during these reactions. So I hope this topic is now clear to you. Thank you.